Today, um, we're doing a bit. Oh, sorry. Did you not understand me when I told you to put that away? I wonder how I can say that better. So today I'm doing the pre-SOHCAHTOA lesson. It's to understand what ratios are. Okay, we are talking about similar triangles. Who has heard the term similar triangles? No. Okay, so I'm going to introduce what a similar triangle is. These triangles are two similar triangles. Let me show you another one. These two triangles are similar triangles. I would like you, how are we going to do this? Abdullahi, why don't you sit next to Kai? Tenzin, why don't you sit next to Clara? And then Daria and Elise, you'll turn around and speak to Claire. Charlotte, apologies. Actually, Abdullahi, come sit here. You can sit next to Michael, and Kai, you turn around and talk to those guys. All right, so the first question is, Miss Sly just told me that these two triangles are similar triangles. What does it mean to have two triangles that are similar? Just take a wild guess. Okay, go. What makes these triangles similar? All right. So, Juliana, what did you guys think? Listen up, folks. We got wisdom coming. Yeah. Gorgeous. Oh, and you even answered my second question, which is so you all talked about what makes them similar, right? So you said they have the same what? Everyone? What do they not have the same? Size, lengths, right? So we're not saying that they're identical triangles, right? We're not saying that. If we said they're identical, we would use the word congruent. These triangles are not congruent, but they are similar. Okay. Now, if they are similar, what I want to see is, okay, so Miss Sly says they're similar. I want to see, what does that mean for the length of the sides? Okay, so watch this. So I'm going to take this smaller triangle and kind of put it in here. Okay, I'll put a dot down right there. Okay, and, oh, the dot disappeared. Fine, I'll put a dot there. And now watch if I put a second one. Okay, so if I'm looking, it's rough, but if I'm looking at the length of this side, how many times bigger is the bigger side? Okay. Well, so it's twice as long. Interesting. So now let me fit this better. Okay. So now, instead of looking at this top, let's look at this longest side, the bottom. Take a guess. How many times longer is the bigger triangle from the smaller one? Yeah. And how about this third side? Yeah. So every single side of the bigger triangle is twice as long as every single side of the smaller triangle. Make sense? Okay. I'm curious about area. So area is like the inside of the triangle, right? How much space does this triangle take? Now, look at it. Imagine how many of these triangles would fit into the bigger one. Talk with your person. All right, so watch this. So fingers up. How many times? Is it 2, 3, 4, 5? Okay. So I've got this. Okay, this is a weird one. I'm just going to kind of estimate it here. Okay, so there's one triangle. Then I put this in here. Here's another triangle. I'm going to put this here. Here's another triangle. Okay, that's weird. So how many is it? Yeah. Interesting. Okay. Well, oh, isn't that cute? Do you like it? It's kind of cute. All right, but that's not what I want to show you. I want to get Cami out. Because I don't want us to be thinking that every triangle is just, that similar triangles are just twice as big, right? That wouldn't always be true. So what if instead I have a triangle, let's make, so for this triangle, can you see how the angles are the same? That the angles match. So if the angles are the same, what kind of triangle is it? It's a similar triangle. Good. All right. Now, how many times longer is the vertical side? How many times longer is the horizontal side? Take a wild guess. How many times longer is the hypotenuse going to be? Yes. As a rule, every single side is going to be the same number times bigger. Now, let's think about the area. How many of these purple triangles are going to fit here? Is it going to be 4 or is it going to be more? I wonder how many. Okay, you guys take a guess. Talk about it. What could it be? Come on up.
Is it 4 marks for this part?
Oh, the whole thing is 4 marks. One
the
question
whole
for
1 and
correctly.
3.
Yeah, 1 and 3. Yeah. All right. Okay, folks, check this out. So what are we thinking? I heard 6. I heard 4.5. I heard 9. All right, we got some answers. Excellent. Folks, put that telephone away. That's not a way. No, that is not a way. Yeah. Like it shouldn't come out. All right, folks. So we've got a bunch of guesses. Can I tell you something? Even if you guessed the wrong answer, but you still guessed, you're good because you're opening your brain up. Okay, you're getting ready to absorb some information. So let's figure out. So I remember that the area of a triangle is base times height divided by 2. So if I take the smaller triangle, I've got 1 times 1 divided by 2, what's that? 1/2, okay, or 0.5. Now, if I take the bigger triangle, it's going to be the same. It's going to be base times height divided by 2. What's that? Well, that's 9/2, or it's 4.5. So, folks, how many times bigger is the big triangle from the little triangle? How do I get from 1/2 to 9/2? 9/1, right? I have to go 1 times 9. The bottom doesn't change. So what we're seeing here is that this triangle is actually 9 times bigger. One, two, three, four, five, six, 7, 8, 9. Yeah.
Can you just square the length of one of the sides to know how many you're doing?
So close. So close. Can you just square the length of one side? Not. So the reason why I say so close is because for this one, yes, you can square it. But what if I have two triangles and it's not a 1-to-3 ratio? What you can do is you can square the ratio. So how many times bigger are the sides? Well, they're 3 times bigger. So how many times bigger is the area? Well, it's 3 squared times bigger. So if I have a triangle that is like a tiny one like this, and this is 1, and this whole thing is 10, right? And this is 1.5, and this whole thing is 15. So how many times bigger is every side? 10. So now the question is, how many times bigger is the area? If the sides are 10 times bigger, how much bigger is the area? 10 squared, which is 100 times bigger. Okay? Now, folks, that is a lot of like conceptual thinking stuff. Okay? Our brains just did the bulk of the thinking, and now we can write it down and then we can practice it. Now, before we go, any questions here? All right, so grab your lesson notebook and let's get started on taking our note about similar triangles. Grab a highlighter as well. It might be nice to have. Yeah. It's the one, Abdullahi, can you show him? Trig. Okay, May 15th. Woo, starting the last unit of the year. Oh my God, I'm so sad. Highlighter. Similar triangles. Highlight what are similar triangles, or underline them if you don't have a highlighter. If I have two triangles that have the same angles and the same side lengths, are they similar? Sure, but they're also congruent. They're identical, right? So the beauty of similar triangles is that they don't need to have the same side lengths. Okay, so before we start, I must teach you how to label triangles. All angles are uppercase letters. A, B, X, Z. All side lengths are lowercase letters. Lowercase a, lowercase b, lowercase x, lowercase z. That's how you know if I'm talking about an angle or a side. Okay? Now, let's give that first triangle a name. Let's call it A, B, and C. So did I just write down the names of the angles or the sides? Good. Now the sides are going to be lowercase. Where do I put, which side is side A? Okay, I want everyone to take a wild guess and point, like actually point at my board. Which one is it? This one, or this one? Which one is side A? Who was right? Who guessed correctly? All right. Which one is side B? Point at it. Did you get it right? And which one is side C? Well, process of elimination says that. So what's the rule? Audrey wants to ask. What is it? What's the rule? How do I know how to name the sides? Yep. No, nothing about that. I could have called it GJK. Give it a shot.
The side is not touching the letter.
I like that. That's one way of saying it. It's the side that's not touching the angle. Okay. What's another way of saying it? There's different ways to explain it. Yeah. That's the one I like. I like to say, not that the first one's wrong, but it's like this. Side A is opposite from angle A. Side C is opposite from angle C. Okay, so that's sort of how we name it. Okay, so let's put that into practice. So I'm going to call this triangle D, E, and F, making it random names, but I would like you to write the name, to label sides. Yeah.
Can you put the ABC on whichever corner you want? You just have
Anywhere. Any letters, any order. The next one, I'll make it random. All right, so write down the letters. Did you get the side lengths? Okay, everyone tell me out loud. What is the name of this side here? This one? This one? Great. Okay. Now, we are told they are similar. Why are they similar? Because they have the same angles. So, how do I show that two triangles have the same angles? Watch this. Angle A is the same as angle D. How many arcs did I put down? 1. Angle C, 2 arcs, is the same as angle F. 2 arcs. Angle B, 3 arcs, is the same as angle E. Doesn't matter which one's bigger. You're just saying, hey, if the number of arcs matches, it means those angles are the same. Okay? Well, now that we have shown on the triangle that they're similar, how do I write down that they're similar? Right? I can't put an equal sign because that wouldn't be true. So I will write triangle ABC. On the other side of the sign, whatever it is, I'm going to write triangle. Now, here is the tricky part. You have to match up the angles. So what's the same as A? D. After A is B. So what's the same as B? E. What's the same as C? F. Right? So the letters have to correspond. And now I'm like, what do I put in the middle? Don't do this, but I really want to put an equal sign. No, they're not equal because that would mean they're identical. Well, should I put like approximately? No. What we do is we put one little squiggle, and that one little squiggle means similar. So we've seen, so when we do approximate, we either do this equal sign, and sometimes you can also use this equal sign. Both of these mean approximate. One squiggle means similar. So one squiggle versus two squiggles actually means a different thing. Okay? So this statement here is me saying, hey, triangle ABC is similar to triangle DEF in that order. Okay? So now there's three properties. Hi. Excellent. Thank you. I have her present because she was here before. So we've actually discovered already the three properties of similar triangles. You might not have noticed it because you were having so much fun. I know. So let's formally write them down. So the first property is if two triangles are similar, then their corresponding angles must be equal. So in the diagram above, I am told, so I write it like this. If triangle ABC is similar to triangle DEF, could I have written FED instead? No, Miss La, you can't, because the angles have to be in the same order. Then, so I'm teaching you some math communication here. So if these two triangles are similar, then we can say with 100% certainty that angle A equals, not squiggle, not approximate, fully equals to angle D. Angle B is identical to angle E. And angle F is identical, oops, I got the order wrong, sorry. And angle C is identical to angle F. Is this making sense? So this is like the law of similar triangles. Okay, so we know that. Obvious. We figured it out a long time ago. Okay, what else have we figured out? Well, we figured out the second property. And the second property says, okay, the angles are the same. What about the side lengths? Well, the side lengths are not the same, but what we can say for sure is that the ratio is the same for all the sides. So if two triangles are similar, then the ratio of their corresponding sides is the same. So a triangle is magnified or shrunk by the same amount each time. One triangle that we did, every side was twice as long. Another triangle we did, every side was 3 times as long. So what do we write down? Well, here we're going to write down if triangle ABC is similar to triangle DEF, comma, then, right, we're writing these like really fancy math sentences, feeling really smart today. So then if I'm like, okay, which triangle is bigger? Is it DEF or ABC? Okay, so I like to have the bigger ones up top because if I go 1 divided by 3, that's uglier than 3 divided by 1. So I put the bigger one on top. So that means that side D compared to side A, right? It might be 3 times bigger. Well, it's going to be identical if I take side E and compare it to side B, and if I take side F and compare it to side C. Right? These are the matching sides. And there's always going to be 3 times bigger. They're always going to be two times bigger. Okay. Yeah.
Do you know this stuff, like which side corresponds? Because B could be 2 different sides. Oh no, it's one side. I got it.
Yeah, you got it. Okay, great. Okay. And let's go to the third property. So wait, let's label this. First property is about angles. Second property is about side lengths. And the third property is about area. So we've just learned 3 important characteristics of similar triangles. So property 3 is about area. So what we found out is that, for example, if sides are 3 times longer, then the area is how much times bigger? If the sides are 3 times longer, what's the area going to be? 3 times 3, which is 9, right? Then the area is 3 squared, 9 times bigger, right? That's what we figured out. Yeah, take one from there. So let's put that down in like formal writing. So if I have the area of triangle DEF and I compare it to the area of triangle ABC, this is going to look weird. I know this might not make sense. When we put numbers to it, it will make better sense. What we're saying is if I take the ratio, so if I'm like, okay, if I have side D divided by side A, and I found out, oh, it's 3 times bigger. Well, to find the ratio, the comparison of the areas, I just have to square it. Yeah, you just need, because every single side is X times bigger, right? Put it away. Even more so. Yeah, I know. All right, so let's actually do some questions with this. Okay, whew, numbers, thank God. Okay, and now we're going to randomize the letters. So, Alex, you had the question. What letter do you want? Okay. Charlotte, I messed up your name today. What letter do you want? Oh, come on. Okay, I'll put a B here. Kaylin, give me a letter. Okay. Grace Graham, give me a letter. C. Okay. Pierce, give me a letter. Okay. And Tenzin, give me a letter. Great. Okay, totally randomized letters, right? So go ahead and write the names of the side lengths. Great. All right, so if those are my letters, that means the sides. Now for L, folks, look at L. This is going to be, if I just write an L like that, I don't know if it's an I or an L. So for L, I use the cursive L. This is B. Then I have A, lowercase c and C. Like that's kind of, okay. Just for practice, let's mark down which angles are the same. Right, so we're doing the arcs, okay? Angle K and B are the same, so I'm doing one arc and one arc. Those are the same. Now we can't easily say how many times bigger the sides are, right? Because it's like, I can see that C and L are corresponding, but it's like 4 and 5. So it's not very clear. It's like 1.2 times bigger, something like that. And what am I supposed to do? Let's read the question carefully and highlight. Okay. I'm still noticing on the test, some people are not reading the question carefully. So let's read it carefully. Find the length missing sides. And let's highlight on the diagram what it is we're trying to solve for. That. Right? There's 2 sides that are missing. Okay, in order to solve for any of the sides, I need at least one pair of corresponding sides that I have both lengths. So luckily, I've got C and L, right? I need to have one pair that like I've got both of them. So I want to show you how we can find, we're going to start with side K. And I go back to my properties and I'm like, I'm talking about side lengths. Oh, so that's property number 2. How do I find a side length? Well, it looks like I'm going to have to write 2 fractions to figure it out. So if I'm looking for K, I'm going to make that green. Which side on the bigger triangle does K correspond to? Say it out loud. Okay. And then, so I have one unknown and one known. Now I have to put one fraction that is complete. So I've got the C and the L. What goes up top? Is it the C or the L? Good. Because it's the same triangle as K. No, I messed up. No, it's the C. Yeah, because it's from the same triangle. It doesn't matter if I put the bigger or smaller on top. For this reason, I said I'm going to put the K on top because that's the one I don't know. But I could have done it the other way. Now, let's put in the numbers that we know. So I don't know the K, but I know that B is 10 centimeters long. I know that C is 4 centimeters long. And I know that L is 5 centimeters long. Please ask. If you're like, how did you get that? Where'd you get that from? Please just ask. Take a wild guess. Talk to the person next to you. Take a wild guess. What will be the length of K? All right. Hearing a lot of 8. Is it going to be 8? We shall see. Now, folks, tell me the strategy or the technique or the tool. How do I solve for the K? I've got 2 fractions. I've got one thing I don't know. Anyone know? Yeah, but it's gonna like so one thing is like, hey, I multiplied by 2. Totally, you could do that. Problem is, it's not always gonna work when you have like really ugly numbers. Yeah. K over 10, 4 over. Is that better? Who's seen this thing where you go this times this times that? What is that called? What is it? Folks, do you know that there is something better than cross multiplication? I know. Let me show it to you. Don't write this down. I was floored when someone taught me the T method. Okay, I'm just going to show you what cross multiplication is. Don't write it down because I've got an easier one. So cross multiplication means you go 5 times k equals 10 times 4. Then you divide everything by 5 and you find that k equals 8. Way too much work. Introducing the T method. Da 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 da. The T method, you draw a diagonal between the two numbers. 10 times 4 divided by 5. Anyone seen that before? So let's just write it down. If you've got it like this, that means we're timesing the longer one. So this is times. This little stick is divide. We're going to practice it 3 times, 4 times today. So what that means is k equals, well, I'm going to go 10 times 4 all divided by 5. That gives me 40 divided by 5. That equals to 8. Who said 8? Pat on the back. Well done. Excellent math guess. Okay, let's practice that T method again. So what we found is we found the length of k, right? Let's put that in the okay, we found that k is 8 centimeters. Well, what do I need to find now? I need to find y. Once again, I'm going to set up 2 fractions. Now, I'm going to show you, we're going to do the T method when the unknown, when the green is on the bottom. So I'm going to put the y on the bottom. Which side corresponds to side y? A. Good. And then the other fraction has to be one where I have 2 sides. So I'm going to use C and L again. So the C goes on top because it's part of the same triangle. The L goes on the bottom. Yeah, thank you. So the C and the A are, so the top numbers are in the same triangle. You got it. Yeah, so I'm going to give 50 points right there for that tiny question. Do you know why? 50. Like Audrey's in the top right now. The reason is I want you to ask such small questions. What happens if you don't ask that question is you get just slightly confused. That confusion does not go away. Then I do something else that is just slightly confusing. So now we've got 2 slightly confusing things. The more and more slightly confusing things that happen, they grow exponentially. And you walk out of that lesson being like, I'm not sure I got it. Now, you ask a tiny clarifying question. You understand it? Guess what? There's nothing confusing, right? You can keep going, fully not distracted. So please ask these questions. They are so, and I will also say, if it's a question that you have, there are at least 3 people in the class that have that question and don't want to ask it. Okay? 100% of the time. Okay? All right. Now I'm keeping this green because that's the one piece I don't know. So let's rewrite this fraction with the information we do know. So what is my A? Well, my A is 6 centimeters. What's my C? It's 4 centimeters. What's my L? It's 5. I'm just taking those numbers from the triangle picture. I need to find out what the Y is because it's my unknown. I could cross multiply, but Miss Sly taught me this wonderful method called the T method. Now watch, everyone look at what I'm doing. Take the two diagonal numbers and I go 6 times 5 divided by 4. I want everyone to say it out loud with me. Okay, first thing we do is 6 times 5. Everyone say it. Divided by 4. Good. Now write it down. So Y equals, and I can write 6 times 5 divided by 4. $30 divided by 4. Well, that's going to be 15 divided by 2. And because I have to put down a measurement, we're not going to write a measurement of 15 over 2 centimeters because that doesn't mean all too much for me, right? So I will write 7.5. And I'll add that to my diagram. So Y is 7.5 centimeters. Should I be using, Kate, the approximate equal sign or just a flat out equal sign? What do you think? Let's ask. I actually want to ask everyone. I shouldn't have just asked one person. That's robbing everyone from the opportunity to think. Okay, everyone, put your thinking caps on. Should I be using, when I found the 7.5, right down here, should I be using the equal sign I did, or should I use approximate? Who says what? Who says, Miss Sly, it's the approximate one? Hands up. Who says it's the flat out equal sign? How come, Ella? That's right. Did I have to cut off any decimal places? No. So if you're not cutting away any information, you don't have to do approximate. Does that make sense? Because it's still exact. All right. Out of curiosity, how many people get the T method? Okay, we're going to do it a couple more times. Do you like it? Do you know why I love it? In this example that we just did, see how the Y was in the denominator? That really tricks people. Like if I give you a fraction to solve and the unknown is in the denominator, folks, students are like, even in grade 11, they're like, how do I get that Y from the bottom? How do I get it out of there? It's like, don't sweat it. Just T method it. It works. Yeah.
Can you still use the cross?
Absolutely. You want to use cross multiplication, please. Please, please, please. All right. So let's answer the question. What did the question ask? Find the lengths of the missing sides. We found them. Therefore, K equals 8 centimeters and Y equals 7.5 centimeters. There you go, Miss Sly. And Miss Sly, I just want to give you like 3 points. Do you know why I give myself 3 points right now? I've never done that. I'm pretty proud of myself. Because I went back and I read the question to make sure that I'm actually answering it, right? If I just kind of leave it blank, I don't know if I actually answered it. Okay, so 3 points, Miss Sly. Thank you, Miss Sly. All right, next question. Go ahead, read the question. Highlight it. No chatting, read it. I'm going to write down that information. Folks, go back to the first page. Which property are we talking about? Yeah, the one we labeled with area. We're talking about property 3. Cool. All right. Who has not had a chance yet? Daria, give me a letter. Pardon? Okay. Kate, give me a letter. Great. Amelia. Great. Michael? Abdullahi? I know. It's hard, right? It's hard to come up with a new letter. I'm teasing. And Sebastian, give me a letter. Okay. So first thing we're going to do is we're going to say if, or not if, because we know they are. We're going to say since the triangles are similar. Now, I'm going to write BXL is similar to, and I want you to write the CTA or CAT or TAC in the correct order. Make sure they're with the corresponding angles. Oh my God, we wrote cat. That's cute. Well, we didn't write it, but we have the letters. Okay, so the corresponding triangle is TCA. Did you get that? And if not, hey, Miss Lai, can you remind me why? Who wants me to say how I got TCA? B, it's like this. B is first. It corresponds to T, so you have to put T first. X is second, goes with C. L is third, goes with A. All right. So since they are similar, yes. No. If you really wanted to write cat, you could have written it a different order. Yeah. So folks, shh. So what we can say is since they are similar, we can compare them. I'm totally, yeah. Okay. I can say the area of triangle BXL over the area of TCA, right? Because when you divide things, you get a ratio. It's 2 times bigger. It's half as big. It's 5 times smaller, right? When you write them in a fraction, it's a ratio, right? We're comparing them. And we found out that the way to do it is that you take 2 sides, you see what their ratio is, and then you square it. So I want you to talk with the person next to you. Which 2 sides should we use? And which number do we put into that fraction? Which goes at the top, which goes at the bottom? Get some agua.
Yeah, we should use L. We could use LMC. Oh yeah. So it is LMC. Or you can use B's. Since we use like 5. No, you divide this looks right. So you divide page 1 by
All right. So folks, which 2 sides am I using? What are the letters of the sides? A and L, excellent. What goes up top? Yeah, how do I know? Well, the L is here. The A is there, right? So I'll put the L and the A, and let's actually in the next line, let's actually put the names down. So, or sorry, not names. Let's put the numbers down. Okay, what are all the numbers we know? Well, I know L is 4 centimeters. I know A is 10 centimeters. And I know that the area of BXL is 8 centimeters. And then what I don't know is area of TCA. Yeah.
Do you put the smaller number on top always?
No. My preference is to put the bigger numbers up top, just because then my ratio is bigger than 1. But it actually doesn't matter at all.
Doesn't matter.
No. So now let's expand this fraction part, this squared part. So I'm going to have 8 over the area. And then what I have with the 4 and the 10 is basically you square each of them. So 4 squared is 16. 10 squared is 100. And now let's practice the T method. Eight times 100 divided by 16. 8 times 100 divided by 16. Now, you can go ahead and go 8 times 100 is 800. Yeah.
Where did you get the 8?
From at the beginning, thank you. Right in the question, it tells us that the area of the first triangle is 8. So it says the area of the first triangle is 8 centimeters squared. And so I'm comparing the area of the first to the area of the second. Thank you. All right. So I could do 800 over 16. Then I most likely need a calculator. I want to do it without a calculator. Watch this. Oh, look. 8 goes into 16 2 times. Right? So if I divide this by 8, I get 1. If I divide 16 by 8, I get 2. Yeah? Can I do it again with the other number? Yep. If I have so now what I have left is 1 times 100 over 2. But I can also simplify. I can cross cancel. I can say, well, 2 goes into 2 1 time, and 2 goes into 100 50 times. Now, all of this can be done in one line, but I'm just showing it. So I've got 1 times 50 over 1, which equals to what? 50. So all of that happens in one line, but just so you see how I cross-canceled. And so I can say, okay, therefore, the area of triangle TCA is exactly 50 centimeters squared. Thank you. People writing a test, you got like 7 minutes left. Okay. I'll give you 2 extra, so 10 minutes left. We good? All right, let's do one more.
No.
This one, we're not going to have a single number in this answer. It's going to be kind of ugly because there's not a single answer. Great, thank you. Okay, I need 5 letters. Who has not given me a letter yet? Audrey, you haven't? Give me a letter. Graham, give me a letter.
J.
Simon, give me a letter. Okay, Waylon, did you give me one? Give me a letter. Excellent letter. Violet, what's a letter? Yeah. All right. Yeah, thanks. Oh. All right, folks, why did I put only one letter where J is? They are the same. How can I say that? Well, good old grade 9 taught us something, didn't it? I hope so. Okay, what did we learn from grade 9? We learned the OAT, the opposite angle theorem. What it tells me is that two angles, please stop talking, that are opposite. So if you have two straight lines, the two opposite angles are identical. So those two are identical. Also, that angle and that angle is identical. OAT, opposite angle theorem. Then we have one that when I have two parallel lines, do you remember the good old PLT, the parallel line theorem? So when I have two lines that are parallel, and the way that I show that they're parallel is I put those arrows, right? And then I take a line called the transversal, and I make it cut through those lines. Then I can use the good old PLTZ, where I draw a Z, and the angles on the inside of the Z are, guess what? Identical. Yeah, we call this the PLT-Z. Because then there was a PLTC, a PLTF. My favorite is definitely PLTZ. It's up there for like one of my favorite theorems. Least favorite theorem, that's for another day, is the Pythagorean theorem. Won't tell you why today. All right. Now, we are going to use this review from grade 9 to help us in this question that says, show why, so I have to show why the two angles are similar. Well, what do we know about why the two triangles are similar? What do we know about similar triangles? All the angles are the same. Okay. So, since, this is how we're going to do it. Since line OM is parallel to line, how do I write? Do I write LV or VL? Actually, before I do that, which angle is identical to angle O? Think PLTZ. Good. Which angle is identical to M? L, right? And I'm like, if I don't know, I actually take out a highlighter and I go Z. Oh, those two inside are the same. Okay. And why can I say that angle J is the same as angle J? OAT, right? All right. But PLTZ only works because these two lines are parallel. So OM is parallel to, do I say LV or VL? Which is the identical? So if O goes first, what goes first? V, because those are the corresponding angles. So VL, and I put a line on top. There's all these ways to show that something is a line. All right, but I'm saying the line between V and L. So since they are parallel, I can say that angle O equals to angle V. I can say that angle M equals to angle L. And why can I say that angle J equals angle J? I can't just write J and J. Watch what I'm going to do. I'm going to say angle OJM equals to angle VJL because of OAT, because of opposite angle theorem. So since all of that, now I can say, therefore, triangle OMJ is similar to triangle VLJ. Really good work today, folks. We did a lot of thinking. We set ourselves up for the next lessons. So please do your homework. You have it in the homework booklet.